Okay, so we're going to introduce now a very important concept, and the concept is compactness. So this is an important topological concept, and let's run through some definitions. So suppose you have a metric space S comma D. A family of open sets is said to be an open cover for E. So you have an open cover for E if E is contained in the union of the elements of that family. Okay, so here's the idea. So the idea is that script U is going to be some set of open sets. Now, things can get tricky when you're talking about sets of sets. So instead of saying a set of open sets, we'll stay safe and just use the phrase family. So if you have a family of open sets, so script U is some collection or family of open sets. And if E is contained in the union of all these open sets, right? So another way to write this is to write E. Well, let me go down a little bit. So another way to write that is to say that E is contained in the union of U sub alpha. Well, let me make it very easy here. U belonging to script U. So you could say U is equal to a set of U sub alpha, alpha in script A. So this is just some indexing set. Could be countable, could be uncountable, could be finite, right? And if U is written like this, then you would say that E is contained in the union of the U sub alpha, and alpha ranges and runs through U sub alpha, alpha runs through big alpha, right? So any way you do it, basically what you're saying is that E, so if in terms of drawing a picture here, you're saying that E is covered by all of the elements in script U. So like here's E, and
It's 11 hours.
Thank you. Script U is a whole bunch of open sets, right? Uncountably many, infinitely many, who knows? And if you can cover E with all of these open sets, then we say that script U is an open cover for E. Okay. Now, a subcover is a subset of a cover, right? So a cover or subcover is finite if it contains only finitely many sets. Okay, this is a key fact here, which is that the sets themselves may be infinite. So the question isn't are the elements of script U finite or infinite? The question is how many elements of script U are actually covering E, right? So if E is a subset, if E is contained in the union, right, then do you need all of those sets in script U? Or can you reduce script U to a finite subcover? Okay. If every open cover of E reduces to a finite subcover, then E is called compact. All right. So E is compact if every open cover of E reduces to a finite subcover. Okay. So let's look at the most this is the very useful theorem, Heine-Borel. And this is a way